going to look at lesson 7.4, which is evaluating unit circle values by a variety of strategies. The first thing I want to do though is look at one of the pages from the investigation you did. So we have 0, 30, 45, 60, and 90. And in radians, it's going to look like this. And so sine of that is 0, and 1/2 root 2 over 2, root 3 over 2, 1, 1. This was all developed on earlier sections when we looked at those special right triangles and everything else. So, all right. So, now we're going to use what we've been working on to fill in this unit circle. So we can call this, I'm going to do angles first. So this is 0, this is pi over 6, pi over 4, pi over 3, pi over 2. Now, see how this is, actually, I'm going to use some different colors. I'll do pi and 3 pi over 2 and then 2 pi. The 45s go pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. This is pi over 6, 5 pi over 6. Here's pi. A sixth more is going to be 7 pi over 6, because that's 1 and 1/6. And then here, 11 pi over 6, because it's 1/6 short of being 2 pi. And then here, pi over 3, 2 pi over 3, 1 1/3, which is 4 pi over 3, and 5 pi over 3. Okay. So as we look at all of those radian measures, you can tell that the ones with the same, in the same color, all have the same denominator. That's going to be really important. Now in degrees, 0 and 360, 90, 180. There was a degree symbol, so I don't know why I put a degrees again, but whatever. And our coordinates here are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Here, you can see how I'm wider than I'm tall. That's root 3 over 2, comma 1/2. And see how I have this triangle right here? This triangle over here is the exact same triangle. This green triangle matches perfectly with that green triangle. So it has the same height of 1/2. Now the only thing that's different is my root 3 over 2, instead of being positive, is going to be negative because it's over to the left. Now this coordinate point's negative root 3 over 2 and negative 1/2. So again, it's that exact same triangle, just down here. Okay, so it's the same distance horizontally, but now that 1/2 is down. And then over here, I'm having the same values, but root 3 over 2 is positive because it has a positive x coordinate, and the 1/2 is negative. Now we'll do the 45s. So this is 45 degrees. This is 135 degrees. This is 225 degrees and 315 degrees. So these coordinates correspond to that 45, 45, 90 triangle. So this is root 2 over 2 and root 2 over 2. I have the same coordinate points because this red triangle over here is the exact same triangle, just mirror image. It's reflected over the y-axis, one might even say. Negative root 2 over 2, positive root 2 over 2. Then I have one down here, which again has the same coordinates, but both x and y are negative because they're third quadrant angles. And then I have one more over here. Okay, and that's positive root 2 over 2, comma negative root 2 over 2. All right, one last round. And this triangle, oh, I didn't put the angle in first. Oh well. I'll draw the triangle first because I started it. So we're 60 degrees, 120 degrees. Oh, I didn't put the 30-degree angle. Oops. 150, 210, 330. Okay. 240, 300. Okay, sorry about that. This triangle, this blue one, is the same as the green one, but it's shorter widthwise than it is tall. So this is 1/2. See how I'm going, this distance is shorter, so that's why the 1/2 needs to be first. And root 3 over 2, negative 1/2 root 3 over 2, both negative. And positive x, negative y. Okay, and so this is the unit circle all filled out. Okay. Something snazzy that you might notice, as you can see, 0, 1, 2, 3, all the way up to that. And I paused on that for 4, but watch this. If I wrote it as square root of 4 over 4 over 2, because everything has the over 2, square root of 4 is 2, 2 over 2 is 1. So it does actually follow with that. How cool. So cosine, when I go to find evaluating with this, cosine of 45, what I do is I go to my 45 degrees, and cosine is the x value. Remember, cosine is x, and sine is y. And that's because opposite versus adjacent. Our opposite, when we have our thetas here, our opposite is the heights, and our adjacents are the side right next to. So x is at 45 degrees, the x value is root 2 over 2. Sine of pi over 6, I'm in radians. I go to my radian one. Pi over 6 is right here. My y value is 1/2. Boom. Tangent of pi over 3. Remember, tangent is y over x. We looked at that the other day. Pi over 3 is right here. So I'm going to have my root 3 over 2 over 1/2. Multiply top and bottom by 2. Comes out as root 3 over 1, which is just root 3. And sine of 150. So I'm going to go to 150. The y value is 1/2. Okay. So again, that was one of the pages out of our investigation, but I wanted to make sure we knew the unit circle and saw those patterns develop. Okay. So now we're going to take a look at in our Dory packet some of the notes. So again, we're going to use a ton of different strategies, and we're looking at the unit circle. So the reference angle is the angle formed by the terminal side of a given angle and the x-axis. Okay, so it's kind of hard to see it on. Let's see if I zoom in a little. Not that bad. So here, see how 315 degrees is on this outside? Our reference angle is actually this little sliver that's on the inside here. So in 240, we measure the reference angle as this piece in here. Okay. Your best bet when you're trying to find a reference angle, and in quadrant 1 they're their own reference angle. So we always want to draw the picture and we measure it to the x-axis, never to the y-axis. And basically, because bow ties are cool. It makes a bow tie. So we always go to the x-axis. Okay, so in quadrant 1, if you have an angle between 0 and 90, it's its own reference angle. If you have something larger than that, if you have something larger than 360, like if you had, I don't know, 390, and we wanted its reference angle, I'm going to show you how I would do that. I would draw my picture. So 390 goes all the way around for 360 and then a little bit more. Okay, so I draw my picture. Next thing I'm doing is I'm going to draw my line down. So 390. This little sliver, I'm going to have to find the coterminal angle. So I'll subtract 360 and get this piece is 30 for my reference angle. A lot of times reference angles are theta prime like that, for how we write it. So let's say I have an angle in quadrant 2. So if I have an angle in quadrant 2, it would be usually something between 90 and 180, but not always. That's only if they're positive angles. So let's start by, let's do 145. Okay, so I'm going to start by drawing my picture. Here's 145. Now I draw my line back down to the x-axis. Okay, and what I'm asking, do we see how this is smaller than a straight line? Since it's smaller than a straight line, I'm going to do 180 minus that 145 to get 35 degrees. Theta prime, my reference angle, is 35 degrees. Okay. Now, if I had something in quadrant 3, so usually, if we're talking about positive angles, we'd be talking about between 180 and 270. But it could be negative angles as well. So I'm going to do one with a negative angle, and this is afterwards. So we're going to do 2 examples in this box. Hopefully we won't run out of space. So let's do 200 degrees, for example. 200 degrees is right here. Okay. See how we are bigger than a straight line? Okay, but not that close to the whole circle. We're still closer to a straight line than we are to a full circle, but we're bigger than that straight line. Since we're bigger than that straight line, I'm going to subtract 180 from it. Basically, I'm doing my subtraction so that I'm resulting with a positive result. 20 degrees, so my reference angle is 20 degrees. Now again, I said I was going to do 2 examples on this one because I could also have a negative angle end up in quadrant 3, like negative 110 degrees. So I'm going to still draw my picture first. So negative 90, like 110 would be like there. Okay. So first thing I'm going to do, draw my line to my x-axis. Again, we do that every single time. And I want to find this angle here. As we look at this, do you see how this is less than 180? It's less than a straight line. I'm going to do 180 minus that 110. Notice I'm not subtracting a negative. I'm just doing the absolute value there. It's 70. So this one's reference angle is 70 degrees. It was a little tricky. So even though I was in quadrant 3, I didn't do the angle minus 180 every single time. I draw my picture first instead. Now, something in quadrant 4. In quadrant 4, we're usually, if we're positive, between 270 and 360 degrees. So let's try a reference angle for, let's do 310 degrees. Boom. 310. I draw to the x-axis. My goal is to find what this little sliver is. See how when I look at all of that, it makes a full circle? That's why I'm going to do 360 minus 310, which is just 50. So my reference angle is 50 I could have a negative angle in that quadrant as well. If I had a negative angle there, like, say, negative 47, my reference angle is just going to be the angle this way. So if this was negative 47, this angle is 47. My reference angle would just be positive 47 degrees. Okay. Express 752 as a reference angle. Again, first thing I'm going to do is draw my picture. 752 is more than one full rotation. It's actually more than two full rotations. So I'm going to do 752, and I'm going to subtract 720. That's 360 times 2. And it comes out as 32. So basically I'm going around once, around a second time, and then to 32 degrees. So my reference angle would be 32 degrees. Write in terms of a reference angle. When we want to write in terms of a reference angle, we need to keep two things in mind. The first thing is to find the actual reference angle. So 230 degrees, that's in quadrant 3. So here's that 230. You can see I'm I'm past a straight line. So I'm going to do 230 minus 180, and that's 50 degrees. Okay. Now the next thing I want to keep in mind is whether sine, and remember sine is the y value, in the third quadrant, will the y value be positive or negative? It would be negative. So this is saying sine of 230 degrees is the same as negative sine of 50 degrees. So you can see it right there on the calculator. Sine of 230 degrees is the same as negative sine of 50 degrees. They're both irrational numbers, but okay. Write the following in terms of a reference angle. So, oh, there's a bunch of these. I'm going to do B out, and I'm going to do E out, and I want you to do the other one. 6. I'm going to do this one as well. I'll do I as well. Okay? So, do cosine of 10 pi over 7. Where is 10 pi over 7? Well, it's bigger than pi. And this is 1.5 pi. 10 sevenths is 1.42. So it's like here-ish. So I'm closer to a straight line than to a whole circle. And so I'm going to take this one, and I'm more than that straight line. So I'm going to do this and subtract pi. Notice I'm subtracting pi instead of 180 because I'm doing this problem in radian mode. So this is 10 pi over 7 minus 7 pi over 7, which is 3 pi over 7. Okay. Now, in the third quadrant, this is negative x and a negative y, which means my cosine is going to be negative. So we're going to write this as negative cosine of 3 pi over 7. Okay, I said I was also going to do this one. E sine of negative 230. So I start by drawing. Now this is a negative angle. It's a little tricky. It's going to rotate clockwise instead of going the other direction. So this ends up about here. Okay, so there's that. This is negative 230 degrees. This is bigger than a line, so I'm going to do 230 minus 180, which comes out as 50 degrees. Now, in this quadrant, my x is negative and my y is positive, so my cosine would be negative and my sine would be positive. I'm looking for sine, so we're going to say that this is the same as positive. Notice I'm not writing a sign in front of it because it's positive sine of 50 degrees. Okay. Now this last one that I wanted to do, sine of 5. Notice there's no degree sign. This is really saying 5 radians, and not 5 pi, just 5 radians. 5 radians is over here-ish. Okay. And so what we want is this little sliver right here. So again, if I was doing it in degrees, I'd do 360, but since I'm not, I'm going to do 2 pi minus 5. 2 pi minus 5 is going to be about 1.28. Okay. So in this quadrant, we have a positive x and a negative y. So this is going to be negative sine of about 1.28. Could also write negative sine of 2 pi minus 5 if you wanted it exact, but it's not a big deal. So again, I'm leaving you the other 1, 2, 3, 4, 5, 6 to try on your own. All right, so how do we use the calculator? I kind of alluded to this a little bit. One of the things on the calculator, though, is we have to keep in mind we're in the correct mode. So if you hit the mode button right here, you can see how there's radian and degree. So depending on which mode my problem's in, I need to be in the correct. So on the last problem I did with sine of 50 degrees, I was in degree mode. If I have a problem that's in radians, I want it to be in radian mode. So I'm going to do these first ones, sine of 125. So first thing I notice, these are all in degrees. So I double check my calculators in degrees. Okay. Now the sine, cosine, and tangent buttons are right here, sine, cosine, and tangent. And the first one was sine of 125. Sorry, I forgot already. Sine of 125. Okay, and it wants me to round my answer to 3 decimal places. Whoop. Covered up the other ones. So we're going to write 0.819. And 3 decimal places means I want 3 numbers after my decimal point. Cosine of 47, sine of 235, cosine, and you can have a negative. You just want to use this negative down here, not a subtraction sign. Notice it looks a little different. Drop those there. Oops. That's fine the way it is. So cosine is 0.682 because the 9 is going to bump the 1 up. Sine of 235 is negative 0.819. So notice these two have the same value other than their opposites. They must have the same reference angle. And negative 0.98. Boom. So for these, I want to be in radian mode. So when I'm in radian mode, I'm going to go to mode, switch it to radian mode, and then type these in. And I'm moving it over so I can see the problem. Cosine of negative 2.5. Actually, yeah, cosine of negative 2.5. And sine of pi, second caret to get the pi over 2. Okay. Oops. There it goes. Sorry. That one's 1. This one is negative 0.801. Go ahead and try the other 4 here on this page on your own. All right, and so the last ones that we have are evaluating, and you're going to do this page on your own as well. You want to find exact answers. So here, this word of exact, that means I don't, no decimal approximations. So the ones we just did with the calculator were decimal approximations. Okay, what I want to use is our unit circle that and that's part of the reason I had the unit circle at the very beginning. So sine of pi over 4, go back to my unit circle, pi over 4 is root 2 over 2. Now, so I did that one for you. Now, here we have a bunch that are not our normal kind of things. Like right here I have cosine of 17 pi over 3, and I have sine of 29 pi over 6. Those are way outside of one full rotation, okay? So we're going to combine these two concepts together. We're going to find the reference angle. Yeah, see where I'm going there? So right off the bat here on sine of 29 pi over 6, the fact that I see a 6 in the bottom, that tells me that it's part of my pi over 6 family. Okay, so it's going to have a reference angle of pi over 6. Okay, sine of pi over 6 is going to be 1/2. So this answer is either going to be positive 1/2 or negative 1/2. The next thing I need to figure out is which quadrant is it in. So 29 over 6, I'm going to use my calculator just for a moment on what 29 divided by 6 is. 4.83. 4.83 pi, roughly. We're repeating on the 3. 1 pi, 2 pi, 3 pi, 4 pi, and then 5 pi over 6. Okay, so this is coterminal to 5 pi over 6. It's going to have a reference angle of pi over 6. Okay, so we're in quadrant 2. In quadrant 2, sine is positive because it's a negative x and a positive y, and sine is the y value. So my answer here is positive 1/2. So again, just to recap, the over 6 tells me I'm part of the pi over 6 squad, which that tells me it's either going to be positive or negative 1/2. I determined based on coterminal angles and spinning around that I must be in quadrant 2. Quadrant 2 sine is positive because it's a positive y value, so then it must be the positive 1/2. So go ahead and try the other 6 that are on there, okay? And you can drop into Zoom to ask any questions you have, okay? Thank you. Have a good day.